In this lesson today, we're going to talk about experimental probability. Experimental probability is what actually happens when you run an experiment. And we can look at the ratio above, and experimental probability is equal to the number of times or favorable outcomes that occur over the number of trials in the experiment. So before we start jumping into an experiment, let's go ahead and review the theoretical probability of these different events occurring. So it says here, what is the theoretical probability of spinning this spinner and landing on a purple? So you can see that there is one purple space out of 4. So the theoretical probability, or the chances of us actually spinning this spinner and landing on a purple, would be 1 out of 4 times. We know that 1/4 is equivalent to about 25% as well. Now, what's the theoretical probability of spinning a green? Well, there's only one section that's green, so it's going to be 1 out of 4 again. For the orange, well, 1 out of 4 again. And the red, 1 out of 4. So you can see that the theoretical probability of us landing on these 4 spaces just happens to be the same because we have 4 equal sections to spin the spinner on. Now, I'm just going to write a little note that this is about 25%. So 25% of the time, we should land on one of those colors. Now, this is the difference between theoretical and experimental probability. In theory, that is what should happen. We should spin the spinner and land on those 4 colors 1 out of 4 times. But when you run an experiment, it's not always going to be equal to the theoretical probability that we calculated. So let's go ahead and let's pretend we ran an experiment. And let's say we took the spinner and we spun the spinner 20 times. So I'm going to go ahead and write that down here. We spun it 20 times. And we're actually going to do this in class, but for right now, since I can't do that on this software program, let's just pretend. And let's go ahead and say that the spinner, once we spun it, we kept a tally of when it landed on purple, green, red, and orange. And let's say that it landed on purple, let's say that it landed 8 times. Let's go ahead and say that once we spun that spinner, out of the 20 times, it landed on the green only 3 times. And then it landed on the orange, let's say 4 times. And let's go ahead and say that it landed on red 5 times. So spinning it 20 times, those are the different colors that it landed on. Now, personally, when I did this experiment, what I did was I tallied. So every time that I landed on a color, I tallied like this. So 1, 2, 3, 4, 5, 6, 7, 8. That's what my experiment would have looked at like as I did each trial. Then my green would be 1, 2, 3. My orange would be 1, 2, 3, 4. And my red would have looked like this. And then, of course, I can go ahead and determine my numbers from my tallies after the experiment is complete. Okay, now let's ask ourselves, what is the experimental probability that we spun a purple? What actually happened when we spun the spinner? Well, we can say that we landed on purple 8 times out of the 20 times that we spun it. So 8/20ths, of course, because both of those are even numbers, it simplifies down, and it's going to simplify down to 2/5. So the chances that this actually occurred in our experiment was 2 out of 5 times. Now, you might be thinking, well, what is the equivalent decimal for that? Well, so what's the percent chance? And our percent chance for the purple is going to be 40%. So if you look back up to our theoretical probability, that you see that in theory, we should have spun it about 25% of the time. But this was actually a little bit greater than what we originally intended with the theoretical probability of 25%. So the point is, when you run an experiment, it could be a little bit off from your theoretical probability. Let's go ahead and now determine the green. So the probability of spinning a green. We spun it 3 out of 20 times. Now, 3 out of 20 does not simplify because we have an odd number and then we have an even number. So we're just going to leave the probability 3 out of 20. So 3 out of the 20 spins was a green. The equivalent decimal is going to be 15%. the equivalent percent is going to be 15%. You can see that it's a little lower than our theoretical probability of 25%, which is okay because it was an experiment, and experimental probability is not equal to what should happen in theory. Okay, let's look at the orange now. It looks like we spun the spinner 4 out of 20 times, and it landed on the orange. So 4 out of 20 are both even numbers. So if I simplify that, that's going to simplify down to 1/5. Now, 1/5 as a decimal is going to give us approximately 20%. You can see that this is actually a little close to our theoretical probability of 25%. It's not quite right on, but it's pretty close. And then finally, our red. What were the chances that we actually landed on a red? Well, 5 out of the 20 times that we spun the spinner. We can simplify that down to 1/4. Well, you can see that our experimental probability with the red actually was the same as our theoretical probability. So in theory, we should have landed on the red 1/4 of the time. And when we ran the experiment, we actually did. So it's kind of cool. Sometimes they equal and sometimes they don't. The equivalent decimal here is going to be, like we said, 25%. Okay, so those are our experimental probabilities of spinning this spinner and doing this experiment. Let's go ahead and try another experiment. Now again, we are going to do this in class, but you can actually try this on your own if you'd like. All you need is a fair coin, which is a coin with a head side and a tail side. So you can use a penny, a nickel, a dime, a quarter, whatever you'd like. Now, before we run an experiment, we need to ask ourselves, what is the theoretical probability of flipping this coin and landing on a heads? What are the chances of that actually happening? So in theory, well, there are two sides to a coin. So in theory, we should land on heads 1/2 of the time. Same thing with tails. We should land on tails, or when we flip it, 1/2 the time. We know that a half and a half is both 50%, right? So let's just keep that in the back of our mind, that both of these, if we land on heads, it should be 50% of the time, and if we land on tails, it should also be 50% of the time. Okay, that's what should happen in theory. Now let's focus our attention on running an experiment. And running an experiment means that we're going to actually have calculated the experimental probability. So what we're going to do in this experiment is we're going to roll a dice 10 times. I'm sorry, not a dice. We're going to flip a coin 10 times, and we're going to keep track of the number of times you land on heads or tails. So let's go ahead and feel free to pause the video and take your coin and flip it 10 times. And keep track using tallies how many times your coin lands on heads and then how many times your coin lands on tails. So let's say that we did an experiment. Feel free to use your information, but I'm just going to make up a situation here. Let's just say that this was my tally. So I landed on heads 7 times, and I landed on tails 3 times. So when I did my experiment, that is actually what happened. So the probability that I land on heads is going to be 7 out of 10 because I flipped the coin 7 times and it landed on heads, and I flipped it a total of 10 times. So the probability is 7 out of 10. So 7 out of 10 does not simplify, so I'm going to leave my probability as 7 out of 10. Now, the experimental probability that I flipped my coin and it landed on a tails was 3 out of 10. 3 out of 10 does not simplify any further, so my probability of landing on a tails was 3 out of 10. Now, let's go ahead and figure out the the percentage of that actually happening. This is an easy percentage because we can just, it's a nice base of 10. So this is going to be 70%, and the tails is going to be 30%. Remember, our theoretical probability up at the top said that we should, in theory, we should land on heads half of the time and tails half of the time. But that didn't happen here in our experiment. Our experiment showed that we actually landed on heads more often than tails. And you can see that experimental probability is sometimes different than what should actually happen in theory. Let's try another one. Let's say that I landed, I flipped my coin 10 times and I landed on heads twice. And then, of course, my tails will be 1, 2, 3, 4, 5, 6, 7, and 8. So I landed on heads twice, and I landed on tails 8 times. So my probability of landing on the heads was 2 out of 10, which, of course, we can simplify that down to 1/5. Now, the decimal for 1/5 is going to be about 20%. I'm sorry, decimal to convert into a percent. Now, let's go ahead and look at the tails. 8 out of 10. 8 out of 10 is just going to be 80%, or here we go, 4 out of 5, which is 80%. So you can see when we did the second round of the experiment, it actually turned out the other way. Tails was way higher than 50%, and heads was way lower than 50%. And sometimes that happens. In an experiment, you don't know what's going to happen. Okay, so feel free to use this area to the right to try a couple more trials with the heads and tails. But I did want to mention one thing. This is kind of interesting, and I can't really show this to you on the video, but the more trials that you have, meaning right now I only flipped a coin 10 times, but let's say we flipped a coin 1,000 times. When you actually do more trials, you're actually going to get closer to your theoretical probability, which is kind of neat. Right now, we've only flipped the coin 10 times, but let's say that you flip it 1,000,000 times. Your experimental probability will more likely get closer to that 50% heads and 50% tails with the more trials that you do. Okay, let's go ahead now and actually look at a problem that gives us some information. All right, it says the table shows the result of 50 rolls of a fair number cube, numbered 1 to 6. Remember, a fair number cube is just a dice. We're also given this chart off to the right where it said the number, so the number of the side of the dice, so we have 1 all the way to 6, and then the frequency. Frequency means how often it occurs. So if we rolled this dice 50 times, it landed on a 1 8 times. It landed on a 2 9 times. It landed on a 3 5 times. That's what actually happened when we did the experiment. Okay, now using that information, let's go ahead and answer some questions. We're going to be jumping back and forth from theoretical to experimental probability. The first question is, according to the table, what was the experimental probability of rolling a 1? Well, if we did the experiment, we know that in the experiment, we rolled the dice 50 times. So that's going to be my denominator number. Now, to find my numerator number, I want to know what were the chances of rolling a 1. Well, let's look up at my chart because my chart gives me my data. Rolling a 1, we did that 8 times. So that would mean that my experimental probability would be 8 times out of the 50 times that we rolled. And, of course, we can simplify that down, and that will simplify down to 4 out of 25. If I want the percentage of that, that would be a 16% chance. So, not very high. Now, what was the theoretical probability of rolling a 1? In theory, what were the chances that I actually should have rolled a 1? Well, in theory, there's only one number 1 on the die, so 1 out of the 6 sides. And 1/6 is simplified, so the equivalent percentage is actually going to be 16%, which it was right on the money, actually. That is exactly, the experiment proved the theoretical probability correct. Okay, let's try another one. What was the experimental probability of rolling a 3? So, again, we're running an experiment, so we have to look up at our data. We know that we rolled the dice 50 times, and we want to focus on the number 3. So you see that we rolled a number 3 5 times. So that's going to be 5 out of the 50 times that we rolled. So, of course, those can be simplified, and that's going to simplify down to 1/10. Now, just out of curiosity here, I'm going to go ahead and calculate the percentage. That's going to be about a 10% chance of that happening. So let's go now and figure out the theoretical probability of that actually happening, rolling a 3. So In theory, there's only 1 3 on the dice, so 1 out of the 6 different sides, which again will be about 16%. So you can see in this example that my theoretical probability and my experimental probability were not the same. Sometimes they are the same, sometimes they're not. It all depends. So in our case, our 3 was the chances of us actually rolling a 3 was a little bit lower than what should have happened, or what was most likely to happen in theory. Alrighty, and that's all we have on experimental probability.